Good day, ma'am. We are the Group 3 and today we will present on the topic Healthcare Resource Allocations. Efficient resource allocation in healthcare is vital for improving patient outcomes and operational efficiency. Hospitals face challenges such as overcrowding, long wait times, and underutilization of staff, which can hinder the quality of care.
The objective is to improve how staff are assigned in a hospital ward to help patients get treated faster, reduce waiting times, use resources better, and ensure high-quality care. This involves finding problems, trying out different staffing plans, and using data to make the hospital run more smoothly and improve patient care.
Step 1. Problem formulation. Before we can solve any issue, it's crucial to clearly identify the problem. In our scenario, the focus is on a hospital ward where patients are experiencing long wait times and reduced quality of care due to staffing inefficiencies. For instance, during peak hours, the staff might be stretched too thin, leading to delayed treatments and frustrations for both patients and healthcare providers. To address this, we need input key from stakeholders like nurses, doctors, and administrative staff who are directly involved in patient flow. Their insights will help us pinpoint specific bottlenecks and pain points, such as understaffed shifts or unpredictable patient volumes. By understanding the problem from multiple perspectives, we're setting a strong foundation for developing an effective simulation model and ultimately better resource allocation strategies.
Step 2. Setting objectives and overall project plan. Let's begin by setting our goals for this project. Primary objective is to increase patient throughput by 25% within the next 6 months. This is an achievable, measurable target which allows us to clearly track progress and outcomes. By focusing on throughput, we're aiming to reduce patient wait times, optimizing bed usage, and enhance the overall patient experience. Overall project plan. We'll now outline the project timeline, resources needed, and key milestones. The timeline will include stages such as assessment, planning, implementation, and evaluation phases. We need to identify essential resources, including staffing, financial support, and any technology requirements. Finally, let's ensure we're aligned with hospital management and key staff members from the outset. This alignment will help foster strong collaboration, ensuring that everyone is moving toward the same goals.
Conceptualization. In this step, we need to develop a clear visual representation of the patient journey in the hospital ward. We also need to use flowcharts to map key steps, including admission, treatment, and discharge. We should highlight interaction between patients and healthcare providers at each stage, such as diagnostic tests and follow-ups. Identify critical variables like patient arrival rates, treatment durations, and staff availability to ensure all aspects of the ward's operation are captured in the model.
Step 4. Data collection. On gathering historical data, we collect data on patient volumes, average treatment times, staff schedules, and resource availability over the past year. Data sources. We utilize electronic health records or EHR, staffing logs, and patient feedback surveys to compile comprehensive datasets.
Step 5. Model translation. Building the simulation model. Use of simulation software like AnyLogic, Arena to translate the conceptual model into a functional simulation. This involves structuring processes, defining resources, and incorporating interaction to replicate real-world operations accurately. Ensure the model is scalable to account for future modifications or additional scenarios.
Step 6. Verification. The verification process ensures that the simulation model accurately represents the real-world operation of the hospital ward. This involves running tests to confirm that the model behaves as expected under various scenarios, ensuring logical consistency in patient flow, staff utilization, and resource allocation processes. An internal review is then conducted in collaboration with clinical staff and stakeholders to compare the model's output with known operational patterns. Any discrepancies identified during the process are addressed to improve the model's reliability and alignment with actual ward conditions.
For step 7, the focus is on validation. It is a critical process to ensure the simulation model reflects real-world conditions accurately. Validation begins by comparing the model's outputs, such as predicted wait times, patient throughput, and resource utilization, with the historical data. For example, if the simulation predicts a 15-minute average wait time during the peak hours, this should align closely with actual records from the similar periods. Next is gathering feedback, involving the stakeholders like clinical staff and administrators to review the model, ensuring it reflects actual processes and identifying areas for improvement. Also, test the model with various scenarios such as patient surges or staffing changes to confirm its adaptability and reliability. Full validation ensures the model supports decision making and it builds stakeholder trust.
Step 8. Experimental design. In this scenario, design experiments to explore various staffing configuration and shift patterns. For example, simulate scenarios with increased night shift staffing versus standard levels. In hypothesis development, formulate hypotheses about how different configurations will impact patient throughput.
Step 9, which is production runs and analysis. And this one, I'm talking about running stimulations and identifying trends. So in running stimulations, we have to execute multiple stimulation runs for each scenario designed in the previous step. That ensures each run accounts for variations in patient arrivals, staff, staffing levels, and ward capacity. This allow for a comprehensive view of how different variables can impact a performance. And for identifying trends, we have to look for trends and patterns in the results and paying a particular attention to how adjustments in staffing levels and patient flow can impact the overall performance on metrics.
Step 10. More runs. We should refine our strategies based on initial findings by running additional simulations to test new ideas or adjustments, such as alternative staffing patterns or scheduling changes. And it's also need to use sensitivity analysis to evaluate how variation in factors like patient arrival rates or staff availability impact outcomes. This iterative process ensures solid and optimized solution customized to the ward's needs.
Step 11. Documentation and reporting. Compiling findings. Document all findings, methodologies, and recommendations in a detailed report. Include visualization like graphs and charts for clarity. Stakeholder presentation. Prepare to present findings to hospital management and clinical staff emphasizing actionable insight.
Step 12. Implementation. Applying recommendations with the plan in place. It's time to put our recommendation into action. We'll work closely with hospital administration to apply staffing adjustment and changes based on the data from our simulations. This hands-on implementation phase will require clear communication and coordination to minimize disruption to current operations. Monitoring performance metrics. To assess the success of these changes, we'll establish a set of metrics for ongoing evaluation. This includes tracking metrics like patient satisfaction scores, patient throughput rates, and wait times. Regular monitoring of these outcomes will allow us to make necessary adjustments and ensure the new strategies are effectively enhancing patient flow and satisfaction post-implementation.
So for the conclusion, as the recap of benefits, we highlight how this structured simulation process can lead to significant improvements in healthcare delivery. We emphasize the potential for better resource allocation, enhanced patient care, and increased operational efficiency. For future considerations, we discuss opportunities for further research or ongoing simulations to continuously optimize healthcare operations as conditions change.